going to talk about net ionic equations. So an equation from reaction that only shows those parts that makes it precipitate. So we have to be able to use our solubility rules to figure out which part of the equation is going to help us make a solid. Alright, so these are the steps in order to do this. First, figure out what type of reaction is occurring. Next, you want to write out the complete reaction, make sure that it's balanced. Then check your solubilities. Your reactants are always going to be aqueous, and then your products, we can see if they're aqueous or if they're going to be a solid based on our solubility rules. You're going to circle the solid, and then you're going to write the solid equation backwards. So we'll figure out how to do that. So here's an example. We have silver 1 nitrate, and that's reacting with sodium iodine. So this here is a double replacement, right? So we're starting with 2 compounds, and we're going to switch our 2 cations. So when we do this, we would get NaNO3, and we'll figure out the state it is in just a second. And then we have silver iodine. So now we check to make sure our charges are balanced. Nitrate is a -1, sodium is a +1, so we're good there. Silver is +1, iodine is -1, so we're good there. It's balanced. Now we need to go to our chart. We have a nitrate here, so what does it say about nitrates? All nitrates are soluble. All nitrates, acetates, ammonium, and group 1 salts. So we have a nitrate, so it's always soluble, which means that this is aqueous. Now let's go over here. We have an iodine, and what does it say about iodines? All chloride, bromides, and iodines except silver, lead, and mercury. So if we're in our soluble column and it says that silver is an exception, that means that this is going to be a solid. So this is going to be our precipitate. So now what we have to do is we know that our product is going to be silver iodine. So we're right now just looking for the ions that are going to make this. So if you go backwards, what are the 2 things that can make it up? We have silver plus iodine. And your reactants are always aqueous. That's what your answer is. Alright, let's do this one together also. Now we have sodium carbonate, and then we have barium nitrate. This is a double replacement also. So we want to replace our sodium with our barium. We want to replace our sodium with our barium here also. So when we put this together, we would get sodium nitrate. And our charges here balance out, so we're good. And then we have barium carbonate. We got a +2, -2, so we're good there also. Now we need to figure out which one here is going to be your solid and which one is going to be aqueous. So if you look in our solubility rules, all nitrates are soluble. So that one's going to be aqueous. So now we have to worry about our carbonates. So all carbonates and phosphates except for group 1A and ammonium. So barium is not in group 1, so we know that this is going to have to be our solid. We're going to circle our solid and write that as our product. Now we go backwards. We have barium, and the charge on barium is +2, plus carbonate, and these are always aqueous, which means that they're in water. You have to remember that ions are always going to be separated in water. And that's it. If you have any questions on this, come into class and we can go over it.